Bismillahirrahmanirrahim. Assalam O Alikum. Dear student, welcome to my YouTube channel Learn with Azam. Today we will start new syllabus KPK Book Foundation Physics SSC-I Unit number 3 Dynamics. Now today we will discuss about SLO base according to FBISE requirement numerical problem question number 4 to 8 in part 2. In previous part we will discuss that question number 1, 2 and 3. In this video we will discuss question number 4 to 8. Now let's start the today lesson in numerical problem question number 4. In question number 4 given statement, you want to move 500 Newton across a level floor. To start the crot moving, you have pulled with a 230 Newton horizontal force. Once the crot break loose and start to move, you can keep it moving at constant velocity only 200 Newton. What are the coefficient of static and kinetic friction? Now, in this question, we can find the coefficient of static friction and also coefficient of kinetic friction. So, first of all, write the given data. In given data, normal force that is equal to the weight. So, force is Fn that is equal to weight W is equal to 500 Newton. Now, static friction Fs that is equal to 230 Newton and kinetic friction that is equal to Fk is equal to 200 Newton. Now we can find the coefficient of static friction μs and coefficient of kinetic friction μk that is equal to question mark. Then we can find the solution. First, find the coefficient of static friction that is μs. For finding μs using the formula of coefficient μs is equal to Fs divided by Fn. Fs stand for static friction and divided by Fn is equal to the friction or normal friction. So μs is equal to Fs divided by Fn is equal to 230 divided by 500. So μs coefficient of static friction is equal to 0.46. Now we can find the coefficient of kinetic friction μk. For finding the μk using the formula μk is equal to Fk divided by Fn. Here Fk is the force of kinetic friction divided by Fn normal force. So μk is equal to 200 divided by 500 that is equal to 0.4. Now we will find the next numerical problem in question number 5. Two bodies of mass 3 kg and 5 kg are tied to a string which is passed over a frictionless pulley. In the pulley has no friction. Find the acceleration of the bodies and tension in the string. So first of all, write the given data. In given data, mass of first body M1 is equal to 5 kg and mass of second body M2 is equal to 3 kg. Both bodies are frictionless pulley, so acceleration due to gravity G is equal to 9.8 meter per second square. Now we can find the acceleration A and tension T. So using the formula, first we find the acceleration A by using the formula A is equal to m1 minus m2 divided by m1 plus m2 into multiply by g. Putting the values, then 5 minus 3, m1 is 5, so 5 minus 3 divided by 5 plus 3 into multiply by 9.8. So first of all, A is equal to 5 minus 3 is equal to 2 and 5 plus 3 is 8 multiply by 9.8. Now 2 divided by 8, that is equal to 0.25 multiplied by value of g 9.8. So the acceleration A is equal to 2.45 meter per second square. Now we can finding the tension T. For tension T, T is equal to 2m1 m2 divided by m1 plus m2 into multiply by g. Putting the values, 2 multiplied by 5 multiplied by 3 divided by 5 plus 3 into multiply by 9.8. Here, first of all, multiplying the values, 2 multiplied by 5, 10, 10 threes are 30. So 30 divided by 8 multiplied by 9.8. First of all, 30 divided by 8 is equal to 3.75 multiplied by 9.8. Now for tension T, we have 3.75 multiplied by 9.8. Multiplying the both values, then tension T is equal to 36.75 meter per second square. Now we can solve the next numerical problem in question number 6. Determine the magnitude of centripetal force exerted by the rim of vehicle. Now car wheel of 45 kg tire. The tire has 0.408 meter radius and rotating at speed of 30 meter per second. First of all, we can write the given data. In given data, mass m is equal to 45 kg. Now radius of tire, radius is noted by small r, so radius is equal to r, that is equal to 0.480 meter. Now we have the speed v is equal to 30 meter per second. Then we can find the centripetal force. Centripetal force is denoted by Fc, so is equal to question mark. Solution, we know that centripetal force is equal to mv square divided by r. By using this formula, Fc is equal to mv square upon r, putting the values. Now Fc is equal to 45 into 30 square divided by 0.480. Taking the square of 30 multiplied by 45, then dividing the value of 0.480. So the centripetal force Fc is equal to 84,375 Newton. That is equal to 8.4375 multiplied by 10 raised to power 4 Newton. Then the centripetal force acting on it is equal to 8.4375 multiplied by 10 raised to power 5 Newton. Now we can write in significant digit centripetal force Fc is equal to 8.44 multiplied by 10 raised to power 4 Newton. Let's start the next numerical problem In numerical problem question number 7, a motorcyclist is moving along a circular wooden track of the death well of the radius of 5 meter at the speed 10 meter per second. If the total mass of motorcycle and the rider is 150 kg, find the magnitude of centripetal force acting on him. Now, first of all, write the given data. Mass of bike and rider, because total mass m is equal to 150 kg, and also the radius r is equal to 5 meter. Given speed v is equal to 10 meter per second. Now we can find that centripetal force. Centripetal force is denoted by Fc is equal to question mark. By using the formula, now we know that centripetal force Fc is equal to mv square upon r. So we know that centripetal force is equal to mv square upon r. Now putting the values, then centripetal force Fc is equal to value of mass m is 150 multiplied by value of speed 10 square divided by 5. Here taking the square of 10 is 100. 100 multiplied by 150 divided by 5. So the centripetal force is equal to 3000 Newton. Now we can say that centripetal force Fc is equal to 3 multiplied by 10 raised to power 3 Newton. Now let's start the last numerical. So numerical problem number 8. In 8 numerical problem given statement, a car of mass 1000 kg is running on circular motorway interchange near with the velocity of 80 meter per second. The radius of circular track of motorway interchange is 800 meter. How much centripetal force is required? First of all, according to the given statement, write the given data. Mass m is equal to 1000 kg and the radius r is equal to 800 meter. But the velocity v is equal to 80 meter per second. Now we can find that centripetal force Fc is equal to question mark. We know that centripetal force is equal to mv square upon r. Then using this formula in solution, we know that centripetal force Fc is equal to mv square upon r. Putting values, then Fc is equal to value of mass m is 1000 and velocity v is 80, so 80 square divided by radius is 800. Now taking the square of 80 multiplied by 1000, the value of this answer divided by 800. Then the centripetal force Fc is equal to 8000 Newton. So the centripetal force Fc is equal to 8 multiplied by 10 raised to power 3 Newton. Subscribe our channel for more videos. Best of luck. Take care. Allah.